Yes, that's great. And I was looking to see if Neil you're on, and here you are. And it's great to have you in a way to have you back into the sessions. After the winning of the award of HITLAB, it's always great to see how things progress. But then I'll ask you a few questions, obviously, and I have to start maybe with a basic one for people. But can you tell us for some and remind us for the others what Soliddd is doing and what Soliddd is about?
Well, we were blessed greatly to be able to discover some brain activity that no one ever realized before. And if anybody wants to hear about it in detail, we have a white paper now that is very explicit. And we've realized that if we present multiple separate in-focus images to all different areas of the retina, the brain can automatically put together stereopsis from that. And in fact, with our beta device that we showed at the Consumer Electronics Show just this January, which was a spectacular success for us, we had 128 separate images, like the brain getting 128 separate eyes and automatically constructing a full field, very well focused, very high acuity image from all these multiple separate, each fairly low acuity image. And there's a lot of things that we can do with that. There are so many applications, but the low-hanging fruit, which you've already proven in preclinical trials last year, is if there's some area of the visual field that's missing, particularly what we tested for was macular degeneration and Stargardt's disease, which present very much the same thing. The visual field gets filled in, and people can see in the full field, even though most of the field may have been blocked previously, because very typically for macular degeneration, it's the central area of the field that's missing. The central area goes to the fovea, which normally gets over 90% of your visual acuity, and yet we allow people to see even if that's totally blocked. And we think it's going to work for many other applications too. So what's Soliddd doing now? We're building our product. And we expect to have lightweight, simple to use electronic glasses. I think by the end of the year in quantity, we will see, when you're manufacturing something, things can happen. We rely on contractors, but we seem to have things nicely progressing. And we've gotten so much tremendous support from investors, from people who have written into info@soliddd.com and all kinds of other ways of contacting us. We have more people on our waiting list than we're going to be able to serve with the first generation of these glasses, and that's fantastic. So we're making the product, and we're also simultaneously making, call it a second product, but in very low quantity test devices that we can use in university hospitals, physicians' offices, and have run people through a number of tests that'll help us code our product as well as understand what we can do for a number of other eye conditions.
That's super interesting, and of course the question that comes right after that is that what brought you to focus on this field of macular degeneration and this field versus another?
Well, I'm an engineer. I know nothing about other than being a fellow who wears glasses, and I know a little bit about as a user, right? Nobody ever sets out to discover something new and actually discovers the thing they set out to discover, right? That would be, I don't know if that ever has happened. We set out to do something that may seem entirely different to you, which is my founding partners and I knew that we could develop a far, far better solution for what's known as auto stereo 3D or 3D without glasses. And my partner in founding the company in particular, his name is Rich Muller. He was a professor at Berkeley. He's now emeritus, brilliant physicist, developed the math so that we could define exactly how much depth and how much crosstalk in what's known as light field imagery or integral imaging arrays. And that allowed us to come up with a prototype that had more depth in 3D space without glasses than anyone had ever thought possible before. I looked at that back a few years ago, and now my father had gone blind from glaucoma before he passed away. And I started to think maybe there's something that we could do with near eye systems. I had an inkling that we could get to where we are now. And took a few years of testing and development and making lenses, and we got there.
That's quite interesting, actually. An engineer. I mean, obviously, there is a lot to say about how you get started to do a discovery and where do you end up. You know, that's also probably called some good opportunism, as you see technology working one way or the other. But maybe I want to go back to what you said at the beginning, giving some maybe an initial window on the technology and what you can do. Can you tell us a little bit more, you know, with these 128 image, how you actually can restore the vision or restore part of the vision for people who would have been blind without this solution?
Yeah, now if you're completely blind, if there's no information getting through the optic nerve, we can't help you. Wonderfully, we had Stevie Wonder visited us at CES. We can't help him. Now, there's other technologies, other science that people are working on that perhaps can help people with really, really severe total blindness. And I wish them well. And I've been aware of some people working on that. But what we're able to work with is if there are some active areas of the retina, and some people who feel like they're almost totally blind now have now tried our test devices. And while they may have just a tiny bit of light coming through in this corner or that corner of one eye, and we play around with our test device a little bit, they find, wow, you've expanded my visual field something like 100, 200, 300%. As I said, there's so many applications for the core technology, we're only scratching the surface. But what we're doing for people with macular degeneration is they get that image multiple times over. And in fact, the product we go to market with later this year will probably have on the order of 180 separate images. The more, the better. And the wider visual field we hit, the better. And we're actually addressing a very, very wide angle of view, much bigger than people get from VR and AR glasses now. And doing so with, what the brain perceives as a stack of multiple images that it puts together automatically. As we go forward, we also are expecting to be able to detect the specific presentation of, in the case of macular degeneration, a scotoma or multiple scotomas that someone might have. And then we can turn off the light to those specific areas and only provide our multiple images to those areas that have good perceptual ability. And we think that should give us even far, far greater performance than what we've already proven in the tests that we've conducted.
And as you have been doing the research and the clinical tests, can you share with us what were your good surprise and maybe your bad surprise as you went through these?
Well, what we've been able to test so far is very limited. And I want to be clear, these are not clinical trials. We've called them preclinical trials. We actually don't need clinical trials to go to market because our device fits into what the FDA classifies as low vision aid devices. There are many of these things out on the market already. They don't do very much. They might magnify the total image, might add some brightness, and people don't use them for very long, even though they're quite expensive. What we were able to test with a very simple prototype last year was reading speed. And we had people look at what's called a Bailey-Lovie test, which is a scrambled word test. And we presented it to people the way that they would normally read it at the same overall visual angle that we could present with our device. And then, or vice versa. We flipped, whether we showed one first or the other first, and we showed a different but similar scrambled word test the way that people could see it through our device. And almost entirely, people read significantly faster with our device. What really surprised me was when people had what they considered to be almost total inability to read or total inability to read. There were many, many times in the trials where people could read with our device and couldn't read at all normally. There were surprises on the other side. If people had fairly, or what might have even looked to an ophthalmologist as quite serious macular degeneration, but were able to read very quickly normally. I mean, some people adapt and know exactly this corner of their vision and can read as quickly as I'm speaking now. We can't make them read faster in that case, right? I mean, how much faster can they go? I can't insist that, a 70-year-old test subject speed read for me. It just doesn't work. There's no way to test it.
And maybe the last question there. I know some people are very eager to hear that, and actually it's a double question. One is, in general, what are the key next steps for Soliddd, but maybe more specific, when will there be a prototype or a V1 available for people actually to get access to?
Well, we think we'll have our golden samples from the manufacturer. We're hoping in the summertime. If everything works well with those devices, that's the product, and we just make more of them. What often happens, though, is that something or other goes wrong. You get a few samples and you fix what's going on in the samples. Now, also, we'll have these test devices, which will be running on a desktop computer and something that the patient will put their head into and get tested for various things. These should be, we can say, quite definitely available in the summertime. We have agreements with a few locations in the United States and in Europe so that people can come into our testing sites. And I think there are many, many people who are eager to do that. So we'll start conducting these tests in the summertime. And at the same time, like any other startup, we're raising more money and we have some deals in place, and that looks good. And we're doing everything you have to do to start up a business, including, meeting payroll for more and more engineers. So.
Well, Neal, that's really exciting. And of course, 15 minutes doesn't make justice to that. And I actually advise people listening to us, to you, if they want to learn more, of course, connect with Neal or reach out to Stan, and we'll make the connection. It's exciting. And I'm sure everybody's looking forward to getting some news from you somewhere in the summer when the first prototype will work. So really looking forward to it.
Thank you very much.